Unit 2, Lesson 5, Part 1, Basic Differentiation Rules. Well, we finally made it to the meat and potatoes of finding the derivative. So we're going to go through the basic derivative rules in this lesson, and then in Lesson 6, we'll go into more advanced rules using our basic derivative rules. So let's get started. So let's start with the most basic one that we need, which is derivative of a constant. The derivative of a constant function is 0. So anytime you're taking a real number's derivative, you are going to get 0. The reason for that is if you're talking about any number c, so if I just draw the graph of any number c, and try actually using the line tool. There we go. This is the graph of y equals c. If you take the derivative of that, the slope of this line is already 0, so the derivative will be 0. So that's why the derivative of a constant is 0. So, for example, the first couple here, these are all constants. The derivative of every one of these, no matter what notation you use, is going to be 0. -4 is a constant, 45 is a constant, 0 is a constant, even k pi over 2, k is considered a constant, so all of those derivatives are 0. Okay, so now, building on that, what if our function is x? We have the line y equals x. So that is this line right here. So this is the line y equals x. So the slope of that is 1. So the slope of this line, our identity line, has a slope of 1. So that means the derivative of the line is going to be 1. So again, no matter what format you use your function notation, f of x, f prime of x will be 1, s of t equals t, s prime of t will equal 1, and x of t, x prime of t will be 1. Okay, so now we get to the power rule. So what if n is a rational number? That's important. It has to be rational. Then we have x raised to a rational number. That means it is differentiable, and its derivative is done like this. You bring the power down, so the power comes in front, and then you subtract 1 from the power. So for instance, the derivative of y equals x squared is going to be y prime equals, so I'm going to bring that 2 down, and then I'm going to lower the power by 1. So y prime will be 2x. So for part B, f prime of x, I'm going to bring the power down and then subtract 1 from the power. So I get f prime of x equals 4x to the third. Now remember, radicals, you want to think of them in terms of their fractional power. So y equal the square root of x is the same as y to the 1/2 power. So now you're going to do the same thing. You bring the power down, subtract 1 from the power. So it's 1/2 minus 1. So you get y prime equals 1/2 times x to the -1/2. So this normally gets written this way. 1/2 times the square root of x, or 1/2 times x to the 1/2. Just depends on how the problem is. Now remember, when you have your base in the denominator, we don't take the derivative of bases in the denominator just like you do if they're like the first one, like this. We don't do it that way. We want to think of this as x to the -1, because that's how the power rule is defined. So for g prime of x, we're going to bring the power down and lower the power by 1, so we're going to get -1 minus 1. So we get g prime of x is equal to negative x to the -2 which is going to be negative 1 over x squared. After a while, you get to a point where you can just do those. So with like making positive exponents without a lot of fanfare. So this is x to the negative 2. So f prime of x is going to be negative 2x to the negative 3. So f prime of x is going to be negative 2 over x to the third. And that goes for fractional exponents too. Remember, this is x to the negative 2/3. So when we subtract 1, we're going to be subtracting 3/3. So we're going to get negative 2/3 x to the negative 2/3 minus 1, which would be negative 3/3. So this is y prime equals negative 2/3 x to the negative 5/3. So our final answer is going to be negative 2 over 3x to the 5/3. Okay? Now you don't have to write that one in radical form because it wasn't given that way anyway. Okay, so our general power rule is, what if we have a coefficient other than 1? So what is going to happen is we're going to multiply the coefficient that is there by the original power of the term. So I'm just going to do a couple of these, and then hopefully you guys will pause the video and then check your answers for the other ones. So for the first one, we are going to bring the power down, and we're going to multiply that times the 2 and then lower the power by 1. So we get y equals 6x. Okay, same thing here. S prime, whoops, I forgot my prime there. S prime of t is going to equal negative 5 times 3 t to the second. So S prime of t is going to equal negative 15 t squared. And then the last one I'm going to do, remember, think of this as 6 times x to the 1/2 power. So y prime is going to equal 3 times x. I was just going to write the answer, but I'll write the intermediate step. 3 times x to the negative 1/2. So this becomes y prime equals 3 over x to the 1/2 power, or 3 over the square root of x. And usually we don't rationalize them, so you leave the radicals in the denominator. Okay, at this point, pause the video and see if you can do the last 3, D through F, by yourself, and then I will put the answers up. Okay, so here's the answers for D, E, and F. And as always, if you did not get those, please ask in class tomorrow. Next, our sum and difference rule. So this allows us to take derivatives of more than monomial polynomials, so polynomials, or even if we have two different types of functions that are connected together, we have an algebraic connection of functions, it allows us to take the derivative of these using our power rules. So the derivative of a sum or a difference is simply going to be the derivative of the first plus the derivative of the second. And same with the subtraction. If you're subtracting two functions and taking the derivative, it'll be the derivative of the first minus the second. So that allows us, like in letter A, to take the derivative of several terms that are put together. So for letter A, we're going to get f prime of x is going to equal 3x squared minus 10x plus 2, and then plus 0. And we usually don't write that. Okay. And I'm going to do one more. So y prime in letter B is going to be 2x to the fourth, because that 5 and the 2/5 5 will cancel, plus 4x to the third plus 6x plus 0. Okay, so again, take a second, do the last two, and then check your answers. And there are the answers to letters C and D. And again, gladly go over them in class if you need it done. All right, then our next rule, oh, we have two more here. I forgot about those two. Okay, so let's go ahead. I'll pause again and let you guys get the answers for these two before I move on toward. All right, so there's E and F. And you want to be careful with letter F. We haven't learned the quotient rule that comes up in the next section. There is a rule that allows you to take the derivative when you're dividing two functions, but even so, because the denominator is just x, it is much easier to rewrite the function by dividing out that x and then using our power rule to find the derivative. Okay, so let's go ahead and look at the first couple of our trig functions, and then I will stop and finish in the next video. So we'll start with the most basic ones, which are cosine, sine, and tangent. So the derivative of sine function is the cosine function. Consider where the sine function increases, the cosine function is positive, and vice versa. So they are kind of opposites of each other. So if you notice here, what you see is here's our sine function in the first picture. It is increasing along here from 0 to pi over 2. And if you look at our cosine function, which is the second picture, that from 0 to pi over 2, this section of the graph is above 0. So that's why they correspond to each other. And then right here, you're going to have y prime is going to equal 0 here if this is a derivative graph, which corresponds to a horizontal tangent line here. And that is also true at 3 pi over 2. So then if you notice that this section of the graph of the derivative is negative, and that's where we are decreasing in the sine graph. So our derivative should be negative there. Okay, so we're below 0. And then again, here we have another 0 here, so y prime equals 0 here. That's at 3 pi over 2, our other horizontal tangent line. And then, of course, we are increasing again on our sine graph, which is above 0 in our derivative graph. So the derivative of the sine graph is cosine x. But it's a little different for the cosine graph. It's backwards. So the derivative of the cosine graph is negative the sine graph. It's the upside down sine graph. And see if you can see that when you look at it. And then the derivative of the tangent graph, and we're going to derive this later after we learn the quotient rule, but we're going to use it for now, is secant squared x. And that might seem a little strange, but you'll see where that comes from. Okay, so I'm going to stop this video here with these three, and we'll pick it up with using them in the next video.